Hi, my name is Clayton Burrows, and I'm going to be talking to you about data and whether or not it's perfect and how it can fit into the modeling process. Data is not perfect. Data is always a close or not close approximation of what we're trying to represent and measure. There are measurement errors, there are recording errors, there are typographic errors, there are clerical errors. But some data sets are still very good. They closely approximate what we're looking at. And of course, this implies others are not. So there's a QC process that has to go in, and we can't just depend on the computer to do this. While it is possible to automate some of the error measurement, it still requires knowledge from the analyst and instructions from the analyst to do these things. But when the analyst is giving the computer the right instructions, we can QC the data, we can build models, and it's a very nice match. We're still doing the thinking, but the task is being executed by the machine. So we're going to look real quick at a example of a possible analytics event that is involving Hadoop. And so we're going to look at the unstructured data, where it's stored, where the analyst may be interacting with it, structuring the data, using machine learning, and then insights for data-driven decision making. So the first little segment of this chart, we're collecting some unstructured data. As my colleague mentioned earlier, we're producing tremendous amounts of data. And if it's copious amounts and it's unstructured, we might use something like a Hadoop distributed file system, which will be running on the cloud, big servers, databases, and we'll probably be using a cluster to interact with those as well. Now, of course, there's an entire amount we could go into on the data engineering behind this, but let's focus on the analytics event. Black box engineering has occurred. Now we move on to the executives and the analysts. There needs to be a discussion and some problem framing. We can't just jump in and start mining and start doing things. So you have to frame the problem with the stakeholders to figure out what they're trying to solve, and then consider, okay, what's the best way to go about solving this? So get in the ballpark, then do the data mining. Now you've got some structured data. And different mining processes will create different structures. So like I said, hopefully you matched the right process for the problem you were trying to solve and the data you had. Now we can apply some machine learning, which is not completely outsourced. We're feeding the data in. We might be doing regression, some sort of Bayesian type analysis, measuring errors, and validating our model. But when we go through that entire process, we'll have something that can give insight, make predictions perhaps, make measurements, find problems we didn't know we had. And that will help the stakeholders make data-driven decisions. Example of this is Yahoo. So not quite the exact flow chart I just showed, but something similar. They had over 200 million users and had no idea what to do with the data. But they were able to do some optimizing and clustering analysis and got that down to about 100 segments. So basically they have about 100 type of users. So they were able to figure out, hey, this person is using this type of product. For example, music, used mostly by young females, turns out. News and finance, mostly male. The email, by far the largest application. In fact, part of the reason people went to that Yahoo webpage was just to get to mail. They didn't realize they could go directly to mail. So this gave them insight on how their products are being used, and they were able to use this to make decisions in how they marketed their products and tried to grow their company. In conclusion, computing power is powerful. Business advantage with analytics is still huge. Lots of businesses are pretty low on this pyramid over here. And it's because it's difficult. Computers don't do this. We instruct computers to do things. It's really still the data scientists and the analysts who are initiating the analytic events and are deciding when, okay, we have a model, let's go out and apply it. This is still being done by humans. Be sure to match the model to the problem. Make sure you're solving the right problem. And then, as always, make data-driven decisions. Don't let shorthand heuristics and biases dominate your life. So thank you very much. We enjoyed making this video and this PowerPoint. I hope you were able to glean a lot from it and that you enjoyed it too.